Atoms, ions. So why would an atom, it's all happy with equal numbers of protons and electrons, why would that atom want to change its number of electrons? Stable? Okay, so we're looking for stability. Electron stability. They want to the atoms are trying to do, or they're seeking out noble gas electron configurations. They just want to match the closest noble gas electron configuration. And we'll talk a couple of ways. I mean, we've seen that a couple of times with the ionics, but we'll also see it with the covalents today. Does an atom that has reacted no longer have the ability to react? What do you think? It's situational, right? If I'm a sodium atom and I've given away my one electron, am I reactive? Not really, but could I made to be reactive? Yeah. If you put energy into it, you can make it react. So we could go to the cell phone battery thing. What do lithium atoms want to do? They want to give that one electron away, right? And so once that one electron has been given away, it doesn't react anymore. It's finished reacting. But what can you then do to make it react again? Plug it into the wall, charge it back up, put the electron back on. So that's the difference. Things will react spontaneously, meaning you don't need to do anything to it. It'll just do something and react. And if you want it to go back to its prior state, you're going to have to shove energy into it. So yes, you can get reactions to reverse. It's just that they will cost you. Yes, if energy is added. No, if not. Which atom is more likely to gain electrons in a chemical reaction, bromine or silicon? The bromine, right? Why the bromine? Only needs one electron. That's one way to think about it. And the other way to think about it is higher electronegativity. So if silicon and bromine were going to make a compound together, what would happen with electrons? Silicon would give up 4 because it's in carbons, and so then you'd need 4 separate bromine atoms, each taking 1. You'd end up with an SiBr4 compound. How many protons and electrons are found in the sulfite polyatomic ion? All right. So the sulfite polyatomic ion, what's the formula for that? SO3 -2. Okay. So sulfur, how many protons do we have? 16 protons for the sulfur, and then for the oxygens? So I have 32 total, 32 total protons.
Isn't it times 3? Yeah,
There's
times
3
3.
oxygens.
24. My bad. So 40?
Yes.
So 40 total protons. Great. And how many electrons?
42.
42. 42 electrons because it's got a -2 charge, which is telling you it has 2 more negatives than positives. So whatever your proton number is, add 2 electrons to that. So those 4 atoms, that sulfur and those 3 oxygens, combined together as a group to garner 2 more electrons. So they took them from something else. But it's not like they stole them, right? The thing that they got them from is probably trying to do what?
Get rid of them.
It wanted to get rid of them anyway. All right? It needed to get rid of 2, and these 4 guys needed 2, so everybody's happy. Ion, what do we got for an ion? A molecule? I don't know if I wouldn't use the word molecule because it could be sodium ion. So I would just say a substance or a particle whose protons and electrons are not equal. And a molecule?
A group of atoms chemically bonded.
Yeah, that part's the important part. Two or more elements. Two or more elements chemically bonded to each other. All right, so our cation, which one's that?
Positive.
Positive. Ion. And our anion? So the positive ion is positive because it lost electrons, and the negative ion is negative because it gained electrons. It's a little backwards in the thinking because the sodium charge goes to +1, but it lost something. It kind of, when you say +1, it kind of connotates that there's a gaining of something, but actually it's a loss of an electron. Why is lithium going to be happy to form a compound with bromine? What's the lithium want to do?
Wants to get rid of one electron.
Wants to lose one electron. And the bromine?
Wants to gain one.
And so the electron configurations before and after it reacts. So lithium is 1s2, 2s1. And after it's Li with a plus charge, 1s2. The lithium is an ion, so we're going to need to put down that little plus chargey thing. And so we're going to do bromine now. So it's Br, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. And bromine ion with a negative charge, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. And there's that extra electron it's gained.